Okay, so today we're going to look at any types of proofs that you might see in Chapter 3. So we're going to prove some of the theorems that we've already taught you and show you kind of where they came from, why they're true. So for this first one, I'm going to give you that angle 1 is a right angle. Okay, so I'm going to go ahead and label that so I know angle 1 is right angle. We want to prove that angle 2 is a right angle. Well, we agree with that. That was one of the theorems that we learned, but why is it true? Let's go through the steps and see if we can figure that out. So what do we notice about angle 1 and 2? Well, the first step that I gave you over here is angle 1 and 3 are vertical angles. That's true, right? Because they're across the street from each other. They share the vertex and they're across from each other. So that's the definition of our vertical angles. That makes sense. Okay, so if they're vertical angles, what do we know about them? If they're vertical angles, then we can go ahead and jump to say, okay, so I know that angle 2 and angle 1 are congruent. That would be the vertical angle theorem. That's the difference between the definition and the theorem. The theorem is actually giving you, hey, those are congruent. Okay, so what changed from step 2 to step 3? My little congruent mark changed to an equal sign. What did we say before we are always using when we go from congruent to equals? We're using the definition of congruent angles or segments. What are we talking about on this one? We're talking about angles. So definition of congruent angles, and I'm going to shorthand it. Okay, so next step, step 4. Angle 1 is a right angle. Well, that looks familiar. That is our given. And we talked about sometimes the givens are in the middle of the statements. That's okay. Okay, so if angle 1 is a right angle, what does that tell us? If it's a right angle, it's equal to 90. What did we use to say right angle really means it's equal to 90? To go from the words to the actual equation, we use the definition of right angles. Okay, so if angle 1 is 90, why can I jump to 90 equals measure of angle 2? Let's see. Angle 2 is on the right side of this equal sign. Where else is it on the right side of the equal sign? Right here. So what changed? How did I go from angle 1 to 90? Well, right above step 5, it says the measure of angle 1 is 90. So what did we do? We grabbed that 90 and we plugged it in, or we substituted it. So if I say that measure of angle 2 equals 90, can I now say that angle 2 is officially a right angle? Yes. By what? How do I go from the equation to the words it's a right angle? We use the definition of right angles. Okay? So there's our first proof. Now let's do another one. Let's get into some parallel lines. So number 2. Number 2, I'm telling you that angle, or line P and line Q are parallel. So I'm going to go ahead and mark those, since we know that they're parallel. Remember, those are either your triangles or little arrows on the lines. And that's the first statement in our proof. P is parallel to Q. All right, so that's our given. Now, what in the world are we proving on this one? We want to prove that angle 1 and 2 are congruent. Do you agree with that statement, that angle 1 and 2 are congruent? Yeah, I agree with that statement, because those would be what kind of angles? Alternate interior. They're opposite sides of the transversal, and they're both between the parallel lines. So we're proving why. Why are alternate interior angles congruent? Let's go through that proof. All right, so our next line. If P is parallel to Q, why would it give us this angle 3? If P is parallel to Q, what do we know about angle 1 and angle 3? What kind of angles are those? Why can I say angle 1 is congruent to angle 3? Well, they're every other. So what kind of angles are those? Those are corresponding angles. And we know corresponding angles, oh my, I can't spell. We know corresponding angles are congruent. So corresponding angles postulate. Okay, my next line. Well, now that I know that angle 1 and angle 3 are congruent, what do I know about angle 3 and angle 2? Why are angle 3 and angle 2 congruent? Well, they're across the street from each other. Remember, anytime we have that X, they're across from each other. They share the vertex. What kind of angles are those? Those would be vertical angles. So to say that they're congruent, we use the vertical angle theorem. So now that angle 1 is congruent to angle 3, and angle 3 is congruent to angle 2, can I now say that angle 1 and 2 are congruent? From my picture, it looks like that, but how did I jump from that? How do I go from angle 1 is congruent to angle 3 is congruent to angle 2, so then I can say angle 1 is congruent to angle 2. What's this property? Okay, remember when angle 3 and angle 3, those are the same. So when I have 3 terms and those middle ones are the same, what are we using? Transitive property. Good. All right, let's do our next one. So another parallel line one. So on this one, I want to prove that angle 1 and 2 are supplementary, okay? If P is parallel to Q, which we're given that it is, do I agree that angle 1 and 2 are supplementary? Yep. Remember, whenever we can draw this little arrow between two parallel lines, we have consecutive interior angles. Consecutive interior angles add to 180. So I agree with that, but why can we say that? What's the proof behind it that made that rule? So let's look at it. So with our proof, if P is parallel to Q, I can say that angle 1 is congruent to angle 3. Well, yeah, that's probably true. Why? Here's angle 1, here's angle 3. What kind of angles are those? Okay, those would be alternate interior angles. Okay, make sure you have your list of definitions by you. So if those are alternate interior angles, we can say that they're congruent. Now, why can I jump from a congruent sign to an equal sign? What are we using? We're using the definition of congruent, we're talking angles, of congruent angles. All right, so I know 1 and 3 are equal, so that's good. Now, can I somehow get from angle 3 to angle 2? Well, angle 2 and 3 are on that straight line together. They're next to each other on a straight line. So what do we know? When two angles are next to each other on a straight line, they form a linear pair. So we just used our definition of a linear pair. Now, what do we know about a linear pair? If angle 2 and 3 form a linear pair and we can draw that half circle, what do we know about them? We know that they add to be 180. So that would be the linear pair postulate. Okay, so angle 2 and angle 3 add to 180. That's good. But how do I go from angle 3 suddenly turns into an angle 1 in the next equation? Why is that? Well, let's go up further up in our proof. What did we say angle 3 equals? Angle 3 equals angle 1. So anytime I have that angle 3, I could just grab this angle 1 and plug it in, or replace it, or substitute it. So we have substitution. All right, now how do we go from an equation to the words? So angle 1 plus angle 2 equals 180, and now we can just say, hey, angle 1 and 2 are supplementary. We use the definition. Definition of what? What kind of angles add to 180? Supplementary ones. Okay, one more. So this one's a little bit different. Now we're going to go backwards, and we're going to prove that line M and line N are parallel. So we're going to prove that. We don't know that yet. So I'm going to tell you that angle 1 and angle 2 are congruent. That's our given. So if angle 1 and angle 2 are congruent, we need to somehow get to knowing something about angle 3, because we need to compare angles on the bottom and the top. Okay? We need to show that all of these guys are congruent, or they add to 180, depending on what definitions that we use. Okay? So let's see what we got. So step 2 says angle 2 and angle 3 are congruent. Why? Why would angle 2 and angle 3 be congruent? Well, we have the x, right? Here's my x. They share a vertex, and they're across from each other. What kind of angles are those? Vertical angles. So we have the vertical angle theorem. So what did that tell us? That just told us the angle 1 and angle 2 are congruent. We're given that. Now angle 2 and angle 3 are congruent. So that's good. Well, it looks like from the picture that now I have angle 1 and angle 3 have the same marks through them, so they would be congruent. Why? Does anyone see it? Let me write it at the bottom. Angle 1 is congruent to angle 2. Angle 2 is congruent to angle 3. Then we jump to angle 1 is congruent to angle 3. So I have 3 terms, which is which property? Transitive. Whoa. So if angle 1 is congruent to angle 2 and angle 1 is congruent to angle 3, I can now officially say that M is parallel to N by the corresponding angles. Now, what word do I have to put on the end of that? Okay. Last lesson, we said if the lines are parallel, then corresponding angles are congruent. Okay. So for this one, what are we using? We're using the converse. We flipped it. If corresponding angles are congruent, then the lines are parallel. We just flip-flopped it. So now we're proving the converse. Okay? So pay attention to whether you're going from parallel lines and using the definitions, or if you're using the definitions and then saying that the lines are parallel. Because if you're using the definitions and then saying the lines are parallel, you're using the converse. Okay, so these are the types of proofs that you're going to see in Chapter 3. We are going to practice these tomorrow. If you have any questions,